Okay, we'll now get started. All right, so today we're going to cover the last lecture of the semester, and then we'll finish off with
Okay, we'll
some.
now get started. All right,
Uh,
so
wow, there is
today
a
we're going to cover
delay.
the last lecture of the semester, and then we'll finish off with okay, we'll now get started.
Hold on one second.
Wow, there.
Okay, sorry about that. I think it's better now. Okay. Um, as I was saying, that today we'll finish the final lecture of the semester. We're going to start off by going over some final concept. As we talked about last time we met, we talked about non-functional requirement and functional requirement when you are designing a software. And today we're going to talk about some of the non-functional relevancy, some non-functional requirements and features of relational databases. Okay. So we've talked about normalizations many times, obviously, and I've always said that we're going to come back here at some point. So far we talk about first and second normal form, and in my mind, those are, in my experience, those are uh, first and second are pretty much a good balance when you think about uh, developing your own database designing. And however, we're going to introduce you two more, which is the third normal form and the boycott normal form, which is the 3.5 normal form. Okay, so just a quick review. The reason, once again, of normalizations are, I'm sure that you guys, after some of those exercises, and then some of you may have studied during spring break, um, understood that, the more normalizations, the purpose of normalizations is so that your design become more efficient when stored, and then uh, trying to eliminate any redundancy, and these redundancy and or so-called bad, not normalized databases uh, sometimes create anomalies. Okay, so in order to avoid these anomalies, as we know that uh, when you're using some type of out-of-box features such as foreign constraints, integrities, etc., it relies on these normalizations so that you don't have these abnormalities occurred, right? So such as the update of anomalies and deletion of anomalies. Okay, so normalization could definitely help out on breaking down these large tables into smaller, more focused entities, right? So this is kind of just reviewing what we talk about. So I'm just going to go through it really quickly and making sure that each entity and their non-functional attributes are being stored within one table, isolating themselves from being break apart and stored in mixed schemas, right? And therefore, your relationship and primary keys and foreign keys, when defined between different entities, you hopefully get to avoid some of these future problems that a non-normalized tables or schemas could cause. All right. And then just a quick review also, functional dependency. Remember, we talk about A, therefore B. When in here, it's X, therefore Y. So the X is the determinant. Y is the dependence, right? So X is normally what we see as the key, where Y is the non-key attributes. All right. So some example here, you can see that, normally roll a roll number, you can get department name, and department building because these are non-key attributes, right? A key attribute normally has ability to get the non-key attributes, right? And so some of the examples are here. And then another review here are all the keys that we've seen before. Primary keys, candidate keys. What are super keys? As we mentioned before, a super key is any combo keys plus another non-key attributes, right? So those are super keys. Imagine supersets, right? When you study math set theories, what a super key is any supersets of a key, okay? All right, and this obviously is familiar. We went through this before. Every step of the way, as you get more and more normalized, you always need to ensure that you first get to the previous stage, right? So if you want to have second normalized form, it needs to be also fulfilled with the first normal form, right? So vice versa for third normal form and even the 3.5 boycott normal form. Okay, so the third normal form builds upon second normal form, okay, and ensures that there are no transitive dependencies. So second normal form, just a quick review, is to ensure that there is no partial dependency, right? Partial keys, partial dependencies, right? And they are built, the third normal form is built upon that, meaning that third normal form ensure that there's no transitive dependencies, but it needs to at least have the second normal form, right? Which means there should not be any partial dependency. Neither should there be, there is also, it also needs to fulfill and be compliant to the first normal form, which is what? No duplicate columns, no multiple values, uh, and what else is there? No duplicate, no mixed domains, right? All of these in order to build upon to get to third normal form. So now what is transitive relationship? Transitive dependency or transitive relationship. Okay. A transitive relationship or transitive dependency means that, as we mentioned, the functional dependency means that normally means that A, therefore B, and then the A or X, therefore Y, the X part, A and X are normally the key attributes, right? So the B and or the Y, which is the dependent, are the non-key attributes. Now, what does the transitive dependency means? It means that B1, therefore B2, or B, therefore C, which is a violation of third normal form. Okay, so what am I actually saying? Meaning that if you can actually find a schema or a table, one of the non-key column can actually be a determinant to another non-key attributes. That means that it's bypassing any dependency on the actual key itself, right? So it's a non-key attributes became dependent on another non-key attributes, right? Or in other words, a non-key attributes happen to be actually found to be determinant for another non-key attribute. So an example here. So actually the scoring tables, student ID and subject ID. Okay. Um, okay. So this here, as an example, maybe not super clear example, is saying that the score of a student on a subject, right, is actually dependent on the exam name, meaning that if the exam name is unique enough, the total mark can be dependent on it. What is the total mark here, though? It's not saying how the student performed. It means that what is the highest score you can get for this exam, right? So again, so let's take a look again. Is this score table, the total marks here, meaning that, for example, your midterm exam is going to be as high as 100 points if you get it perfect, right? And so that exam name is CSC 336, Spring 2026 exam, right? And so that marks actually is dependent not only on the subject ID, it could actually be determined by the exam name. So this is one of the example. Now, we'll come back to maybe more example, but first, let's look at what this Boycott normal form is. So this is also known as 3.5. Okay, it's not even 4. So I don't know why it doesn't just go up to 4, but there are a different fourth normal form and fifth normal form all the way to like seventh normal form, but this is not. This is the 3.5, okay? BC and F. All right, so what is the BC in an example? It means that you have a reversed dependency or trivial dependency. That will be a violation of a 3.5 normal form. So what is a trivial dependency? It means that you now, instead of X, therefore Y, you can actually have Y written in a way so that Y, therefore X. So it's opposite direction. A non-key attribute can be actual non-key attribute can be actual determinant for the key, right? So, for example, here in Roman tables, right, the professor actually could be determined by the subject. So the subject itself is a key, is the candidate key or a uh, part of the combo key here. But with the professor, for example, myself, you can determine that it would be CSC 336. Okay. So in that case, it's a violation. So you need to make sure for the BCMF NF, you need to make sure that the reverse trivial dependency does not exist. Okay. This is another example. Okay. Um, for example, over here, there's a drinker table. Okay, it has a name, and beer liked, manufacturer, and favorite beer. Okay, and then by manufacturer, right, you could determine the beers liked, or by address, you can determine the name, right? So this is examples of reversed dependency. And that is, my friend, a violation of BCNF. Okay, some of more example here you can see. Now, I am not going to get into detail on how you would decompose them. Obviously, it won't be on an exam, but that is not the reason that I'm not going to really talk about how to do it. I would say that in high level, in a nutshell, remember I spoke about when we first get introduced to normalization is that at some point, at some point, the higher of normalization become a lot harder to detect. At the same time, the more and more normalized your tables, your database are, it became, in my experience, slightly too complicated, and it increased, sort of the join count, like the amount of join that you need to make. And it's kind of counterintuitive and then also counterproductive. So, although we still need to learn the basic of normalizations, at least for this course, and then there's obviously good reason that there's more normalizations out there, and then it's going to be beneficial for a lot of, you know, scenarios such as machine learnings and or these data science or data normalization or data mining, right? So there are definitely benefit of it. But for up to this course, practical reason, I think in my experience, up to two is a good enough. And that's why our test is going to cover how to get to second normal form and also how to make sure if you see violations of first normal form or second normal form, how do we make it so that it get into a proper second normal form. Now, third and 3.5, there's going to be more detail of normalizations and examples in the appendix. So if you're interested in learning, you can go and take a look. However, I would say on a nutshell, a key would be the key to do two or 3 or 3.5 normal form. I think the key here is to think about making your table in your database, entities, all that, you know, alias of, tables, entities, schema, making sure that those table, number one, all the info that's stored in one single table, besides those transitive table, obviously, or junction table, obviously, any other table, it should just have attributes and information of its own. Try not to have any other entities, detail, or informations or data store in a schema that they don't belong to. So that's key number one. Number two is starting from third normal form and up, starting from the second normal form, even though second normal, their strategy, how do we make sure that, we get to second normal form, which is by breaking out to a transit table and etc., right? Those are actually tip and shortcuts for us to make sure that our design conform to second normal form. But actual in disguise, starting from the second normal form, one rule of thumb is to create primary keys brand new and normally single rather than combo primary keys on a table. Okay, so it's just an industry-wide known thing that if you want your table to be normalized and it all fit into the right places if you follow these two things. Number one is to make sure that your data are being stored following first and second normal form, and then making sure that the data of an entity is isolated in just that table. Otherwise, the transit tables or junction table, that's an exception. But if there is the student to make sure that all the actual details or attributes describing a student stored just in students, okay? Nothing else that's mixing enrollment, registration, course name, and whatever in there. Like that's number one. Number two is when you create tables. Although we learn about candidate keys, we learn about combo keys, supersets keys, super keys, and stuff like that. It turns out that starting second normal form, the key is always brand new primary keys, single column, brand new primary keys. Nothing from using first and last name plus the birthday combo keys. It's somehow always help. And it just help you get your third and 3.5, get it fit into the right place, is by creating that separate primary key. Okay? And obviously, the way that your primary keys is created, I would say like obviously auto generate, auto increment, those are the strategies, right? Unique values, but on its own and new, nothing coming from any of your attributes or candidate keys of the table. All right, so if you're interested in learning more about normalizations, in the higher level, there is appendix on this deck I will share after this class, and you are free to read. Now, the next thing after that is important for us is the database connectivities. And when I meant database connectivity, I meant by how do you bridge your Node.js, and or your Python, your Java, right? Um, how do you bridge those with database, right? We know that front end, your React.js, and to your Node or Express.js, you could probably have it speak to each other using APIs. But that is not normally, API is connected through HTTPS, right? That is not how, however, the most effective way for database connections with your app, right? So all the way to the back end, there's TCP/IP normally are being used. And by using that channel, normally a database and the language that you're using has a library, almost like that library, think of it almost like a library when you or like a driver when you are buying like a new printer, for example, and your laptop will download that driver, and with that driver, you will be able to, let's say, print via Bluetooth or whatever to the printer from your laptop that you just bought, right? That driver bridge your laptop and your printer. So we'll look at what are these drivers per se for Java and Python. And very simple, right? So this is this is the connection string that you will need to connect. Okay, and this very straightforward. So you will import ODBC for Python. And when we talk about Java, it will be JDBC. Okay. And basically, there's nothing really to say about. There's this connection string that you need to declare. And once you declare, and as you can see, obviously, there, for the purpose of just understanding and explaining, there's server name, right? The driver is SQL Server. In this case, SQL Server is Microsoft SQL Server, right? Rather than MySQL or PostgreSQL. Server name, you give a server name, database name, and user IDs and password. Okay? Let's say once you provide these information, now for the purpose of explaining, we have this, all the connection strings show up, but obviously when you're writing in real life, not your project, but in real life, meaning like at work and stuff, these password and username obviously going to be stored in another better place, like credential vaults or some other property files and stuff, right? That you can store these like constant uh informations. After you have this connection set up or declare, then you connect it, you initiate it with the cursor. Okay, so that cursor is your connection string. Okay, so that cursor is now, it's like a singleton. Can think of it almost like a singleton. Uh, it's a singleton design here. So this cursor is now where you're going to use to execute a SQL statement directly or calling a store procedure. Okay, so as you see, the third line here is where you use this singleton cursor to execute the store procedure, right? And these executions will allow you to make that request, right? And that request is going to now be executed based on the statement you provided, as well as the parameter if there needs to be one. But however, in order for you to actually obtain the result, you need to use cursor.fetchAll to actually contain the results, right? You have successfully executed it and it's now in your cursor, but you need to do a fetch all in order to get your actual data back and store back to your Python. And in this case, rows, which is where we are storing all the results. And then you can now parse the rows using this library of the ODBC, whichever, right? And then obviously at the end, don't forget to close your connection so that there's no memory leak. Now, this is a very straightforward, simple. Obviously, there's much more normally people would do in this case, where like your rows, you'll probably parse it so that you'll probably store that into like a array list or whatever that you need to do, right, with your result. But at least this is explaining to you how you now obtain the driver, connecting, as you can see, with a username and password to your database from your Python code. And this connection is passed through standardized, default, more effective, efficient connection, which is through TCP/IP, right? It's not through HTTP, which means it's not through the actual internet. It's through intranet. Okay. All right, and this is just example for Java. So in Java, instead of ODBC, it will be JDBC. Okay, everything else is about similar, the same. There's not that much difference. Okay. All right, so quickly, let's store the attendance, get the attendance down. Everybody scan the QR code. You get 2 minutes to do so. And while people are taking attendance, any questions so far regarding connection strings regarding third or 3.5 normalized forms? Okay. All right. Okay, so this is just an example. Again, as we mentioned last, as we learned last time, we learned about store procedure. And this is just kind of a example when you actually have a name of a store procedure. Uh, and then you're fetching the result sets. Okay, now this is completely separate topic, but we are going to talk about from this point on, we're going to be talking about extensions from last week, last time we met before spring break. We talked about store procedure, how did it come about, and we mentioned about SQL injections and stuff like that, right? So modern day today, obviously there's definitely multiple options of database. That's number one, we know. We also know that it's no longer just PHP and Miami, which is what we know as well. And there's confusions and questions, and there's also about vulnerabilities with just exposing SQL queries on your JavaScript or HTML, right? And we use store procedure for that. And today, modern technology, especially web technology per se, there's so many other options, regardless of the type of library or the type of database, right? And so all that we are going to talk about in a high level, what it comes down to, what it looks like for these different stack, right? Right. And then what is the networking actually doing, right, with the database? But because of these different stack, or should I say different layers of the stack, right? There's front end, there's middle tier, which is where your app is. There's front end, which is where React.js and whatever. There's your backend container, which is Node.js or Express.js, right? Then you have to all the way to the back where is your data container, which is MySQL, MongoDB, and all that stuff. Because there are all these different stack, you see that before you involve with databases, there is just front end and there's Node.js. And for development purposes, it's very straightforward and very easy for you to check in to a repo, whether that is GitHub or it is something like CSV, right? It's very easy. But now, in order to collaborate, the database, however, the database itself is a struggle. It is hardly able for you to have that database collaborated using GitHub or whatnot, right? Or CSV, right? So the most beneficial way for you to collaborate when you have this full stack development involving data, databases, is to have a container such as Docker, right? To orchestrate your stack, to mimic your stack, and store these container and different components of the of your stack into containers. And these container, once being orchestrated on an image, it will allow you to easily mobilize your entire stack and install your application on clean slate. If it has to be on-premises installation stack or in AWS cloud or whatnot, right? So this is the benefit of Docker, allowing you to have ability to collaborate and very quickly install different install, we like to say image when you talk about containerizations, but very easily porting your full stack of image into a new environment or a new deployment or in your cloud, right? So those are the reason why using Docker this semester will give you extra credits if you try. Okay. Now, this is the database and internet application. So assuming that we all sort of have an idea, right? So internet before any network were to reach internet, it's your laptop, your computer, or your phone, right? And those are what we like to call clients, right? The client and client device per se, right? And within the client device, you have client-facing applications, okay? And those applications is empowered by internet, and that internet normally is HTTP or HTTPS protocol, and it connects to the server, right? And the server is where, for the host or the application owner, would have the data or dynamic or the functionality and hosting those functionality on. Okay, so the three layer that we spoke about earlier, the first will be the client applications, client-facing program, which is enabled by the web browser, right? Those are web browser will be able to translate HTML or JavaScript, right? And then application server is where like such as your Apache or Node.js or whatever hosting on your Java or your Python, okay? Then the database system, the final layer, that's where you will host your statements, your obviously schemas, tables, and everything, and your store procedures. Okay, the three tiers architecture are these. Presentation layer normally is where interfacing with your end user, your clients, right? And then this is what displayed on your table, tablets, your cell phone, or your computers. Middle tier is normally where your business logic is being stored, right? It's processing uh, whatever client's inputs and then making some, receiving it, and then do some pre-processing and or to retrieve using the business logic to all the way to the back, which is the database or your data storage, right? And then back to your application again to do calculations or whatnot, or you can have the calculation done on your database server as well, all the way to the back end. But most likely, you will probably draw those database back, the data result back, and then you process the business logic normally on your middle tier. So the good advantage of these type of three tiers architecture today is that it obviously um, encapsulate the sensitive data from the front end, and not only by one layer but two layer down, right? So it's more secure and it um, allow microservices to be spun off from your application layer, meaning a microservice is meaning that your application layer that connects to your database could be more than one, meaning that you can have more than one application, right? An application server, and then each application server can just do one function. And and they can all still talk to the database. But the good news on these one functions is that it creates API to speak to the front end, but it just focus one server just focus on one features or not that many features. That ways what we call microservices, right? And the reason that microservices is preferable these days is because that it's easier to manage by different teams, right? Rather than you have one mainframe server, application server that had everything written on it, and everything that's written on it not only on one server, but it's all very cohesively uh, glued together. Like, for example, you have a login feature that could be as simple as just a user type in username and password and then log in, and that's success. But a mainframe or a traditional one that is not microservice oriented will be log in plus purchase plus shipping, all combined into one single feature or steps. And that makes developing, debugging, or managing a lot harder. And when you need to upgrade that, also it become a lot more complicated too. So what advantage of three-tier architecture also uh, is bringing is that microservices architecture benefits. Um, It is, however, more difficult to build a third tier application at the get-go, obviously, because it normally means that the job is more distributed, right? And so therefore, instead of one single-minded person build out everything, right? And that's kind of how teamwork get into the places here, right? So by distributing tasks, it by nature will make a software development slightly harder, and then you'll learn about that in your designing courses. But however, and then also it will be harder for microservices for a new joiner to pick up because obviously there's multiple things to learn rather than just one big uh, subject, I guess. So, but there's also pros and cons of it, right? And then it's been proven that microservices or third tier architecture is a preferable options. Okay, now let's talk about data governance, right? So this will be the last bit that we are going to be really covering for this course. And it is just sort of a concept that you guys should at least know in the back of your head is that obviously we know data matters. Uh, and it's very important these days to use data to make informed decisions, right? And then calculated risk when you're taking on a new or more challenging start or project, right? Using data um, is very important. But having the fact that you have data storage allow you to be able to have dynamic applications, sure, and then be able to help you have ways to edit it and all that we talked about at the very beginning, right? And then really easy to retrieve your data, but at the same time store it, backup, and all that stuff. But we also need to make sure that, there are ways that we protect our data, right? And the ways that we are protecting our data is in several different ways. It could be by default, given some feature from the database type that you choose, such as MySQL or Oracle, whatever database that you choose, and or having certain support systems um, or provisioning framework, right? Embedded when you're given this ability to design your database or have access or the rights to certain sensitive data. Okay, so as I mentioned, data governance not only enable or ensure that there's policy in places or standards and tools in place, but it also managed the data availability to certain people, usability, integrity, and security. But last but not least, it also helping through data management throughout its life cycle. Okay, obviously, if we don't have any data governance, then we will have breaches to sensitive data, inaccurate reporting to make incorrect business decisions, um, data inefficiency or silos that causing people or multiple people doing the same job or duplications of efforts or failure to meet regulatory requirements and resulting in legal penalties. Okay, so as I mentioned, ways to implementations of data governance is by establishing or provisioning policy and standards, right? Writing documentations and stuff, or by defining, this is where we are going to be diving in about is defining data roles and responsibility, right? And data roles and responsibility meaning that not just developers, but actual readers who can read what, right, of these data. Let's say not saying logging onto the database or logging onto your Workbench client to read the data, but are these data when it's being retrieved to the end user, what can these end users see? What can they not see even, right? So there's these data roles to be defined as well. Implement data quality management process, enforcing data security measures, and then conducting auditings and compliance checks, and provide your, let me see, is there questions? There's some questions about wouldn't this be more of a job for cybersecurity specific? I mean, yes, but yes, but I guess it's very broad. It is normally, um, at least from my experience, there's normally a risk or compliance team that manage a lot of these governance and all that. That's correct. But normally those teams are large and then they're encompassed and then overseeing a lot of different stuff. And then there are most likely a team that is focusing on, I don't know how big the team will be or how explicit that they would do, but they would normally be a team that focusing on data, right? But let's say, regardless if this team is within compliance or risk or whatever, department, it has to be someone knowing the product, right? They need to somehow know what they're talking about. They if they don't know about the database that the company uses or the user uses, all they can do is making very generic, high level decisions, right? And in some cases, maybe that still is fine because maybe the risk team eventually provisions some sort of framework and it still end up to be the developer or DBA's database administrator to implement at the end, right? These role entitlements and security. So either way, this specific data governance knowledge is important for developers to know about what is available and then what is sort of the most common and popular task when it comes to data governance, um, that normally comes down to uh, software developer when they're designing software to implement some of these easy tasks so that their database are designed to meet some of these risk framework or compliance framework. All right. So obviously, as you can see, even in this deck, right? So data governance is not just by the team that's managing risk, the team that's managing compliance, right? It over this deck, there's so many different bullets. For example, the very last one, providing data governance trainings and awareness program. Obviously, it's probably not a job for developers, but you can see that it's going to be an effort that is collaborated across different teams. All right. So introducing for a software developer to know, the most common and easy thing that a software developer, when they're designing databases, and then they're actually going live about it to restrict sensitive data and access, is by number one, user entitlement, right? And then we're going to look at role-based entitlement, but what is user-based entitlement? User-based entitlement first is by allowing certain privilege to a specific login, specific users, right? And okay, so you're letting a user be, let's say Sheng, like I get my own using my uh let's say using my window account or using my SSO, whatever, single sign-on, C Sheng, let's say that's my ID, for example, right? And let's say when I develop a database or a table, whatever, and I was a developer and I'm going to be the person that's say managing the entire database, so I get an admin rights. And that admin rights means it has everything from delete table, whatever. It's given to me. Now, if Johnny, who is my colleagues, needs it, one way to do it is by saying that adding all these different rights to Johnny's ID as well. That is a user-based entitlement, so based on every single user. Now, what is a role-based? Role-based means that you have a group of people that are potentially having the same privilege to certain data in the database and schema, right? So you create almost a group, in this case, is known as a role, right? But they're really interchangeable to many database, but role-based just means that you're provisioning, permissioning into a group-based entitlements. You're providing this role that say, if this role is managers, or if this role is admin, it will be having more entitlement than analyst or than some contractor, for example, or end users, right? I'm just making things up, but and then you're adding these users, individual user into the role. Now, one person could be in multiple roles, right? That's fine. But the point here is you're permissioning entitlements to a group. Now, that groups could contain multiple users, right? And that is what a role-based entitlement indicates in database. All right. Now, What I need to let you guys know is that in addition to using row-based entitlements, when you actually sit on your desk as a developer in the future, when you're developing a full stack development or you're now designing your database and it's going live, uh, you can get very niche into as little as cell level access. Maybe not just single cell, but it could be as close as to a cell. Let's say if a table just have one attributes, right? Because you can restrict a row-based entitlement to not only entity level, which is the table, or specific columns, but you can actually also restricted access to rows. Okay. And in that case, a row, and in addition to a column level access, it could be even as small as one single cell. Okay. Just so you know that relational database normally come in the feature out of the box, allowing your row-based entitlement to define as small as a single cell, right? But maybe that's way too beyond out there to only limit to a single cell, too granular. But at least this is something you should know is that not only certain table, and within that table, certain column, but also you can also define certain type of rows, whether it's row 1 to row 50 or rows that has passwords or rows that has year before it's 19 born before 1980, etc. Okay. Now, the way that you would use to grant these roles and privileges is by two ways. Obviously, everything in a relational database, modern relational database, MySQL, our Oracle, Microsoft, you can always use their UI, their user interface. But obviously, we know we can also use SQL for a relational database. There is a third type of language called data control language. So we learn about DML and we learn about DDL, definition and manipulation, but there is also another type of language that's data control language. And these data control language are normally used on providing and provisioning privileges, as well as revoking privileges. Okay. So as a contract file system, normally think about your window, think about your PC, right? Your files are normally files or installations are normally typically you can grant rights to read, write, and execute, right? A file system, you can also grant rights to a group or all user or owner. But SQL privileges identify even relationships, right? It also include different type of privilege. There's a total of 9 out there. It's not just read, write, execute. Okay. It also grant or revoked, allow these privileges to be granted or revoked under these relationship. Select, insert, delete, update statements. Right to query the relationship using select, or maybe right to insert tuples, okay? Or right to delete or update. It can get these granular using SQL. All right. So, for example, for the statement below, insert into a beer name, select beer from the sales where not existent, blah, blah. So the privilege select on sales and beers and insert beer or beer.name. Hold on one second. Beers that do not appear in beers. We add them to beers with a null manufacturer where not exists. Name. Beers that do not appear, not exist in beer, we add them to with the insert into beer name. Select from statement. We require privilege. Okay. So it just inserting the names of the beer that doesn't exist in beers. It just select from sell. Oh, so insert into the beer inventory from the sales table where the beer name doesn't exist in the beer's inventory yet. Okay. So in here, we will require the privilege to select on sales and select on beers, and we will require the privilege to insert on beers or beers names. Okay. Here are some of the key words of DCL. Okay, so grant on to. Okay, grant what and normally follow grant followed by the list of privileges, on followed by relation or schema or an object, to whom. So here is an example. Grant select update on price on sales table to Sally. Sally is the authorization, meaning this is by user, right? This is to a user, not to a row. Okay, suppose we want to give Sally not only the privilege, but allowing her to also have the grant privilege, passing on the granting privilege. We also need to grant that privilege to Sally. So grant update on sales to Sally with grant options. So this means Sally not only can update an attributes on sale, but can now grant other to up to other this privilege updating on sales. Now, revoke is just the opposite of grant, right? Everything else is the same. Okay, now we also, when we talk about revoke, just like when we are deleting or cascading, updating with foreign keys, there's also cascade and restrict options in here. Now, just so you guys know that when you do that, there's these integrity involved, right? And I'm not going to get into most detail of it, but the other thing I do want to really quickly talk about before we finish today is that take a look at this, is that not only there are integrity that associate to grant and revoke in SQL, but when me, who is Shane, I grant Sally the grant privilege of blah, 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 of task A, that's it. And Sally grant the privilege to John, right? If I revoked the privilege that I granted to Sally, this revoke is going to pass down from Sally to Johnny as well. So this is one thing that I do want to get just so that you guys aware of the concept is that anything that involving on this sort of like generational or like skipping revoke is going to get passed down. So if A granted something to B and B granted something to C, A revoking the something from B, then B and C is automatically going to get revoked as well for the same privilege. Okay. Well, hopefully these are some of the concept, and then if you're interested on these final sort of topics that has to do with some non-functional features and requirements, and then needs to know basis sort of uh, relational database characters, you are free to take a look at all the appendix. But as far as lecture-wise, that will be all for today. Now, I'm going to stay behind for a little bit if you guys have any questions on today's subject, or if you have been studying and then you have some questions on the course materials specifically associated to the midterm. Okay? Otherwise, you are free to go. And I will see you in 2 weeks, I believe. Next week, I'm giving you guys a new break, I believe, um, for you to study. So there's no class. But then I will see you in 2 weeks in person for the final for the exam, right? So next week is the 20th, which has no class. Okay. If you don't have any questions, you are free to go.
Have a good one, Professor.
Bye.
Have a good day, Professor.
Recording stopped.